Now, I would say most of us are stuck. Okay? Some of you came up with a strategy, which is wonderful. But most of us are stuck because up till now, our main strategies that we've used, our number one strategy is change things to sine and cos. So we look at this one and go, oh, that's already done. Everything's changed to sine and cos already. Well, then after we change things to sine and cos, then our next main strategy was to write both sides as a single fraction. And we look at this one, and that's already done. So our two main strategies that solve almost all of our proofs are change things to sine and cos, and then write things as a single fraction. And in this case, both of those things are done. So what do we do? Well, the strategy that I see some of you doing, the technical term for the strategy is multiply by the conjugate. Now, I'll use the word conjugate a couple times, but it is a word that most people don't recognize when we talk about mathematics, and it's not an easy word to remember because you don't use it often. And so I call this strategy that we're going to use build the other side. So there's going to be times where you get build the other side, We're going to get situations where both sides are a single fraction, they don't match, there's nothing that we can do with the strategies we have so far. So what we're going to do is build the other side. Even the strategy of factoring that we had the other day, nothing here can be factored. And so the build the other side strategy says, well, what would it look like if I at least make my denominators the same? So if I want to make my denominators the same, this side has a sine theta on the bottom, this side has a cos theta. And we're not moving anything from side to side, but we're just going to multiply by 1. If I want a 1 plus cos theta on the bottom here, and I put it there, the only way I can do that is that if I also multiply the top by 1 plus cos theta. And on this side, if I want a common denominator, I would have to multiply by sine, so I'm going to need to multiply the top by sine as well. Because if I multiply a fraction by sine over sine, I'm multiplying by 1. And if you multiply by 1, you just change how it looks, but you don't change what it's equal to. And so now on both sides, and I'm not going to actually multiply out the bottom, I'm going to leave it factored. I have a common denominator of sine theta times 1 plus cos theta. Now, in my numerators, I think the right-hand side is easier. What is sine times sine? Sine squared. And on the left-hand side, I have 1 plus cos theta times a 1 minus cos theta. So we're going to multiply that out. You could FOIL it all out, but maybe you recognize it as a difference of squares. And when you have a difference of squares is when you're multiplying two conjugates. Now, we don't use that word very often in math, but all a conjugate is in math is the same terms in a binomial with a different sign. One has plus, one has minus. And that's called the conjugate. And when you multiply two conjugates, you get a difference of squares, because if I FOIL this out, I'll get 1 times 1, which is 1. My outside is negative cos, my inside is positive cos. Those cancel out. And then my last terms give me negative cos squared. So I get just 1 minus cos squared, a difference of squares. And so what we've done at this point is we've got our denominators the same. So we feel like we're a little bit closer. And now we just have to look at our numerators. Is there anything I can do to my numerators to make them the same? 1 minus cos squared is equal to sine squared, right? You have sine squared plus cos squared equals 1. You can rearrange that formula with one step to get 1 minus cos squared. And so you can change that to sine squared and a little bit of a happy dance because they're the same. And it is okay when you finally get a tough proof to let out a little scream of joy or a little yes, like a little fist pump, whatever you need to do, right? If during the provincial exam, if every once in a while you hear, yeah, you know what, that's okay. You don't want to yell it too loud to scare people beside you, but it's okay to be a little bit excited.
Do we write provincial exams here?
They will figure out the room allocation. It'll either be in here, but since I have 2 classes, they might put us in the library. So.
And then if it is here, do you cover all that up?
Yeah. Well, except most of those are on your formula sheet, so I don't have to cover them up. Because sine squared plus cos squared is 1 is on your formula sheet. Tan squared plus 1 equals secant squared is on your formula sheet. So most of them are on there. So let's look at the second proof. Again, when we're looking at a proof, we analyze the situation. We say, is there a shortcut for us? Is there a way that I can change everything to the same function? In this one, I've got cos on the other side. Cosecant squared changes to sine squared. So I can't change everything to one function. So then our main strategy of changing things to sine and cos makes sense, and getting a single fraction. I'll do the right-hand side, you can do the left. So to get the right-hand side to sine squared, cosecant squared is 1 over sine squared. And we get 2 over sine squared. Single fraction, I'm done the left-hand side. That's a little bit mean, because the right-hand side is more work. That's your job. You have to get the right-hand side. It's a fraction plus a fraction to a single fraction. Once you've got it, call me over. Adding the fractions here. At first it feels like we're making it way more complicated because this is grouped together and this is grouped together, and although they look similar, they're not the same. So when you want a common denominator, this one needs to be multiplied by 1 plus cos theta, and the top will be multiplied by 1 plus cos theta, and this one by 1 minus cos theta and 1 minus cos theta. And sometimes it feels like, wow, I'm making things more complicated than they need to be. This is getting really big. But on the bottom, now that I have a common denominator, and maybe you recognize that they're a difference of squares, you can go right away and write 1 minus cos squared. And on the top, you'll have 1 plus cos theta plus 1 minus cos theta. At this point, on the top, combining your like terms, 1 plus 1 is 2, and the cos theta minus cos theta goes away. And on the bottom, you have 1 minus cos squared, which is equal to sine squared. So our left side is equal to our right side. We are excited and done. So at this point, especially with part A in this one where we were introduced to build the other side, you have now seen all the main strategies for proofs. And you're ready to enter into level 2 and level 3 proofs. So on that sheet, questions 1 through 20, those ones I would call level 1 proofs. 20 through 30, those ones are level 2. And then 30 to 47, those ones are level 3. Okay? There's only one that you can't do on there. Okay? One you can't do, number 45, uses some advanced factoring that you haven't learned. If you've done everything else and want to see that, I'll show it to you. Okay? So on that sheet, number 45, you can't do that one. Number 46, you're going to find really hard because it uses some advanced grade 9 math. Now it does, and that's what makes it really hard. So you have the skills to do it, but you're going to find 46 hard because it uses some advanced grade 9 math. So see if you can figure that one out. But 45, once you've done everything else, you can check that. Now before we're going to use the most of the rest of class to work on that. But before we do that, I'd like you to turn to page 420 and we can now summarize all of the strategies that we've done so far. So I've got a list here. I'm going to talk about them a little bit. I'm going to put a number 1 beside those ones because that is our number 1 strategy that we use when we don't know what to do to start. You can change things to sine and cos and write both sides as a common fraction. So if you get a single fraction on both sides and change things to sine and cos, 80 to 90% of proofs, if you do that, you will solve them and they'll be done. Or you'll just have one little step left to do. Now, the problem with that main strategy is sometimes there are faster strategies. In particular, if you can use a Pythagorean identity, if it appears tan squared plus 1 in a question, you should change it to secant squared right away. It'll make your proof easier. So there's a couple of points here that talk about Pythagorean identities. I'll put a green dot beside them. Like, if you see a 1 in a question on one side but not a 1 in the question on the other side, chances are a Pythagorean identity is going to come up and you're going to need to use it. So if you see a plus 1 on one side, be aware of that. Okay? Now, that also sort of connects to this strategy right here. We don't necessarily just look at a question and automatically change things to sine and cos and start right away. We want to be aware of what's on both sides and think about both sides to see if we can see a strategy that might be faster. Like we had one question which the one side was cotangent and the other side was cotangent and a cosecant squared. Well, the cosecant squared could be changed to cotangent squared plus 1, and then you get both sides all in cotangent. And that was a lot easier way to prove it than changing to sine and cosine. Okay? With the Pythagorean identities that you have, you need to have them 98% memorized, which means you need to know them well enough so that when you see a possibility in a question, your mind goes, hey, that's one of my formulas. And if you need to just double check it to make sure you wrote it right, is it like if you can like, oh, is it tan squared plus 1 or is it secant squared plus 1? I forget. Well, you've got your formula sheet for that. But you need to have them memorized so that you can pick it out of a proof. Because if you don't have them memorized, you won't see things while you're working on a proof. So all of our formulas, even though they're on our formula sheet, we need to know them really, really well. Now, the strategies that we were introduced to today, the build the other side and multiply by the conjugate, are basically the same strategy, just different words. I find that build the other side triggers you quicker to think what you need to do. That you need to, let's make our denominators the same. And if we have our denominators the same in a question that we can't do anything else, then chances are we'll be able to solve the rest of it. So the build the other side strategy is a strategy we looked at today. I'm going to call that, I'm going to put a big S, super blinking S. When you get stuck, so you've used your main strategies, you've changed to sine and cos, you've got a common fraction, and things don't match up, and you'll be like, Mr. JR, I'm stuck. I don't know what to do. When you're stuck, there are two strategies on here that you should get triggered. One is build the other side, and the other one is to factor. So I'm going to call those our stuck strategies. You've tried everything, and you say, I can't get this. I'm going to look through your work. And sometimes you can't get it because you made a mistake early, right? If you make a mistake in an identity, you make something that's no longer an identity, and it's impossible to prove. You'll be spending all day on it. So sometimes we make a mistake that can't be solved. But sometimes